Starting section 2.4, use postulates and diagrams. I have the 4 postulates we learned back in chapter 1, postulate 1, 2, 3, and 4. You can go back and recopy them into your notes, but they're very important and we're going to use them. But moving on, we have a lot more postulates to look at. Yes, I said a lot more postulates to look at. Point, line, and plane postulates. All of these have to do with points, lines, and planes. You can read through them. I would write them down because I'm requiring you to put all vocabulary into your notes. Postulate 5, through any 2 points there exists exactly 1 line. Postulate 6, a line contains at least 2 points. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. Postulate 8, through any 3 non-collinear points there exists exactly 1 plane. Postulate 9, a plane contains at least 3 non-collinear points. Postulate 10, if 2 points lie in a plane, then the line containing them lies in the plane. Postulate 11, if 2 planes intersect, then their intersection is a line. Let's use this information. So state the postulate illustrated by the diagram. I assume you've written all those down so you can go back and refer to them. Here I have if this, which looks like 2 lines intersecting, then that. So that would be the, let's see, if 2 lines intersect, then their intersection is exactly 1 point, and that is postulate 7. Okay? B, if this looks like 2 planes intersecting, then I have this thing here. Looks like a line to me. So postulate 11 says if 2 planes intersect, then their intersection is a line. So this would be postulate 11. Example 2. Use the diagram to write examples of postulates 9 and 10. So I'm using the diagram. This diagram looks like 2 planes intersecting. I see a point on 1 plane, lines on some planes. So let's look and see what postulate 9 says. A plane contains at least 3 non-collinear points. So I see here that a plane contains at least 3 nonlinear points. But I'm going to say the plane contains, if I look at plane P, I can see that there's a B on it, a C, and an A. Okay, so I'm going to say the plane contains points B, A, and C, or ABC, or anything else. And that is plane P. Let's write that in. Plane P contains points B, A, and C. Postulate 10. If you go back one, let's see what postulate 10 says. If 2 points lie in a plane, then the line containing them lies in the plane. Alright, so looking at this diagram, if I have 2 points lying in a plane, then the line containing them lies in the plane. So I have point, let's write that right, point A and B. You can circle that in blue. Point A and B lie in plane P. So line N, right here, line N, which is this line right here. So line N containing A and B also lies in plane P. Okay, you try one. Use the diagram in example 2. Which postulate allows you to say that the intersection of plane P and plane Q is a line? Push pause. All right, postulate 11 says, if two planes intersect, then their intersection is a line. And that's the one we use for this. You try. Use the diagram in example 2 to write examples of postulates 5, 6, and 7. Push pause. There you go. Postulate 5. Line N passes through points A and B. Line N passes through points A and B. Postulate 6. Line N contains both points A and B. Postulate 7. Line M and line N intersect at point A. All right, here's a little reminder. When you interpret a diagram, you can assume information about size or measure only if it is marked. Okay? You guys quite often will see two lines intersecting and assume that these are equal, but they are not. That was from the last test. A lot of people made that mistake. So, read through this concept summary. When you interpret a diagram, you can assume information about size or measure only if it is marked. Okay, you can assume all points shown are coplanar. I have one plane here. You can assume that they're all on the plane. You can assume that angle AHB and BHD are a linear pair. You can assume AHF and BHD are vertical angles. You can assume that A, H, J, and D are collinear because they're on one line. You can assume AD and BF intersect at H. You cannot assume G, F, and E are collinear because they're not on a line. You cannot assume BF and CE intersect. You cannot assume that BF and CE do not intersect because you can't see the whole plane. You cannot assume BHA and CJA are congruent. All right? You cannot assume AD and BF are perpendicular, or that the measure of AHB is 90 degrees. None of that's said in this diagram, so you cannot make those assumptions. All right, sketch a diagram showing line TV intersecting segment PQ at point W so that segment TW is congruent to segment WV. So I need to draw, it's the second time I've done that, there we go. I need to draw a line and label it TV. Now I have to draw a segment PQ that intersects TV at point W. So I'm going to go ahead and draw point W now so I can get it basically in the middle. Okay, and then I know how to draw segment PQ. And it doesn't have to be equal there. Okay, so now I know that those are equal. And I have TW, segment TW being congruent to segment WV. All right, perpendicular. Here's a definition for you. A line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So let me try to draw a diagram. I've told you guys I'm not that good at three-dimensional, but that's all right. We can use our imaginations. There's a plane. Okay? I'm going to try to draw a line that, if that plane were laying flat, this would be going straight up and underneath. Okay? And that is going to intersect right there. So that line is coming straight up and straight down. Okay? And it hits, well, so let's read this. A line is a line perpendicular to a plane. A line is a line perpendicular to a plane if and only if the line intersects the plane in a point, which is right there, and is perpendicular to every line in the plane that intersects at that point. So I could have, there's a line here that's in the plane. There's a line here that's in the plane. There are an infinite amount of lines in that plane. But we can say that, I shouldn't have drawn those in red. This line is perpendicular to that line. This line is perpendicular to that line. And that's how it looks. As pretty as that looks. All right, let's move on. All right, interpret a diagram in 3 dimensions. Which of the following statements cannot be assumed from the diagram? A, B, and F are collinear. A, B, and F. I think that is true. E, B, and D are collinear. Okay, there is no line drawn between E, B, and D. So you cannot assume that is true. Segment AB is perpendicular to plane S. I have segment AB right here is perpendicular to plane S. This tells me that's true. Segment CD is perpendicular to plane T. Segment CD is perpendicular to plane T. There's no line, there's no box thing that says that's true. So we're going to cross that one off. Line AF intersects line BC at point B. I believe that one is also true. Okay, you try. In questions 3 and 4, refer back to example 3. And I've drawn example 3 here. So, if the given information stated segment PW and segment QW are congruent, how would you indicate that in the diagram? Okay. If you remember, we learned if something is congruent, we put a tick mark. Well, segments TW and WV already have a tick mark. So why don't we go ahead and put 2 tick marks here? And that shows me that this segment and this segment are congruent to each other, and this segment and this segment are congruent to each other. Next, you try. Oh, that was a you try. Darn it, you guys just got a free one. I'm going to push pause this time, and you guys are going to go ahead and try it on your own. There you go. There's one more. You try, push pause, and finish it off. That was easy. The answer is yes, and I lied. There is one more after this. Explain, how would you know that line AB is perpendicular to line BC in example 4? Push pause, please. All right. This is the definition of perpendicular, which is why it's so important that we memorize our definitions. We know that line AB is perpendicular to plane S because it was given in example 4. So, line AB is perpendicular to every line in the plane that intersects at point B. Pretty cool. All right, daily homework quiz. I'm going to go ahead and push pause and write some answers, but we'll go over them in detail tomorrow too. Next. Pause. All right, that one's false. Postulate 11 says if 2 planes intersect, their intersection's a line, not a point. All right, push pause. This problem didn't ask us to explain, so we can just push false. All right, pause. Yep, that one's true. Last one, push pause. That's it, section 2-4.